From quantum potential to layered organization. A threshold-based ontological framework. Irfan Boko, independent researcher, Ontology and Consciousness Studies. Abstract. This paper proposes a layered ontological framework in which the foundational ground of physical reality is not particles but energy field potential, and structural organization emerges through critical threshold events. In this model, spacetime is not initially given. It arises as a stabilized phase following an organizational transition. The Big Bang is interpreted not as a metaphysical absolute beginning but as the first observable macroscopic stabilization event. Gravitation is not an independent force but the dynamical consequence of stabilized geometry. Einstein, 1915. The direction of time does not originate in the threshold itself but follows from low-entropy initial conditions. Penrose, 1979. Carroll, 2010. The threshold principle appears analogically across scales. This work proposes a structural ontological framework rather than a new empirical physical theory. 1. Foundational ground. Energy field potential. The starting assumption of this model is that the ontological ground of reality is not discrete particles but energy field potential. At this level, classical geometry is undefined, spacetime coordinates are not stabilized, and organization has not yet taken form. This condition does not imply a temporal before. Time itself is not yet defined. The priority described here is structural rather than chronological. Ravelli, 2004. Van Ramsdonk, 2010. 2. The organizational threshold. Structural emergence occurs through a critical threshold condition. Conceptual threshold function. Theta equals G_E times C. dG_E equals energy density gradient. C equals correlation, informational complexity measure. D equals entropic dispersive tendency. Stabilization condition. Theta greater than or equal to 1. This inequality does not introduce a new physical law. Rather, it represents a structural explanatory scheme analogous to phase transitions in non-equilibrium systems. Prigogine, 1980. The threshold may be understood physically as symmetry breaking or equilibrium disruption, mathematically as exceeding a critical value, and ontologically as the emergence of differentiation. It marks the transition from unstable potential to a stabilized phase. 3. First macroscopic stabilization, the Big Bang. In observable cosmology, the first macroscopic organizational threshold corresponds to what is known as the Big Bang. Within this framework, the Big Bang is not an absolute metaphysical beginning but the first large-scale stabilization event. It represents the emergence of spacetime organization. This threshold establishes low-entropy initial conditions. The arrow of time arises not from the threshold function itself but from these low-entropy conditions. Penrose, 1979. Carroll, 2010. 4. Emergence of spacetime. When informational complexity reaches a critical configuration, relational order forms. This relational order may be described geometrically. Spacetime, in this view, is a stabilized organizational geometric phase rather than a fundamental entity. 5. Gravitation, the dynamical consequence of geometry. Einstein field equation, G_ equals 8T_, Einstein, 1915. In this model, gravitation is not an independent force but the dynamical behavior of stabilized geometry. Ontologically, gravitation follows geometric organization rather than preceding it. 6. Entropy and the direction of time. Time is not treated as fundamental but as the ordered succession of stabilized organizational states. Its direction arises from low-entropy initial conditions. Penrose, 1979. Carroll, 2010. Under the second law of thermodynamics, total entropy increases while local organization may also increase. Entropy is therefore not the opposite of organization but the directional ground within which organization unfolds. 7. The principle of layered recurrence. The threshold mechanism is not confined to cosmological scale. Analogical structural transitions can be observed across scales. A gravitational collapse of gas clouds into stars are energy configurations of atoms forming molecules are critical interactions in biological systems producing organisms. These examples do not imply mechanical identity but structural similarity. Parameters differ, yet the underlying organizational logic remains consistent. 8. Limit of organizational time. G_0 theta 0. If energy gradients vanish, no further macroscopic stabilization can occur.